So the instructional video for Math 20-1, which is 1.5. And 1.5, we talk about infinite geometric series. You can talk about infinite geometric, sequences or series, but we're going to focus on the series. So we are still adding those terms together, and we're going to introduce two words, which are convergent and divergent. And they really do mean exactly what their definition is. Convergent means that this actually converges to a number, and that's maybe a bit of a circular definition. Convergent is the idea that if we let this series keep going, eventually it approaches an actual number. And they show this is from your textbook, that if we look at the series 4 plus 2 plus 1 plus 0.5 plus 0.25, eventually, because this series is getting closer and closer to 0, the value of the next term becomes so small that it doesn't really significantly impact the series sum. And it is one of those important ideas that the only time this actually has what we call an infinite sum is when we let it go on forever. And it's one of the first times that we talk about this concept of really infinity mathematically, that if we keep letting this series get smaller and smaller and smaller, it's never going to reach 0. You can't divide by a number to get 0, but it's going to get so close that it's practically 0. Now, that doesn't always happen. We do have convergent, which will approach an actual sum, but we also have divergent. And I really would like to try to get Mary both these series in the same page here, that look at the convergent series, 4, 2, 1, 0.5, and so on. Now look at the divergent. It's 4, it's 8, it's 16, it's 32. This divergent series, the terms aren't approaching 0. So the sum of this series gets larger and larger and larger and larger, really without what we call bounds. So it's going to keep on getting bigger and bigger and bigger and never actually approach a number. Now, the way that we can identify whether it's convergent or divergent, they show a little bit of a derivation here. We don't need to worry about that. We have to make sure that R is in between 1 and -1. If that R value, that common ratio, is in between -1 and +1, then we can find what we call the infinite sum of that geometric series by using term 1 divided by 1 minus R. And they show that with the formula we had at the beginning. If we look at 4 plus 2 plus 1 plus 0.5 plus 0.25, 0.125 would be next, and so on. That common ratio is 0.5, right? 2 divided by 4 is 0.5, 1 divided by 2 is 0.5, and 0.5 divided by 1 is 0.5. So because that common ratio is in between -1 and +1, we can use this formula. I guess I should be circling up here. This formula right here, the first term is 4, the common ratio is 0.5. So the sum, if we let this series go forever, is +8. And it is an important concept that as we go further in math, we are going to talk about the idea that sometimes when you look at what we typically call infinitesimals, you can actually get some nice kind of integer concrete values. And that's a really important connection in math that we often exploit in calculus to solve a lot of real world problems. So the new thing in 1.5 is that if you have that common ratio, it needs to be geometric. There is no infinite arithmetic series, so don't worry about that. It needs to be geometric. If the common ratio is in between -1 and +1, you can find the infinite sum. If the common ratio isn't, it's divergent, and you would have to use the formula from, or the formulas, I should say, from 1.4. Okay, we'll do some examples here, and that should help you really get used to using this formula.